Let's Make It is brought to you by Ting, the new way everyone is getting their cell service. No overage penalties, great rates, keep what you do not use, no contracts, and someone will actually pick up the phone when you need support. Use our link and get $25 off your first month's service or your new phone. Just go to tech-zen.tv/ting to save $25. Hello, it's Monday, 9 p.m. Eastern Time. It is time for another Let's Make It, and I'm here again this week, and we have Bob. How you doing, Bob?
I'm doing good. How are you?
Doing good. It's been a busy week for you?
Indeed it has, but it's I've gotten some good things done.
Good. So this week, we are going to talk about a request from a viewer that I had a few weeks back. I'm sorry, I can't remember the name and I can't find the email, about using an Arduino as a virtual keyboard and a virtual mouse. So we're going to walk through that. And actually, we're going to talk about some different ways. After I thought about this, I have a project coming up that I may actually use this on to control a kiosk type computer. And I'm going to talk about that a little bit as well. But before we go too far, we've had some viewer feedback this week. Rob D. Do you remember his last name?
I don't believe I ever saw it.
Yeah, I saw him, so Rob D. So I don't know what his last name is. He had sent us an email about the Rainbow Arduino. And it's a very neat, I didn't know what it was. I thought it was a straight Arduino, but it actually ends up being an Arduino with some specialized chips for doing LED matrices. And they look like they can be combined together, butted together. Did it say how many can be put together to make a bigger one?
I know that you can get, hold on. Actually, I believe I still have the data sheet up.
It's very interesting. I mean, I'm not quite sure how the linking together part works. Is it running I2C across similar chipsets and not using the Arduino, or is it an Arduino each one talking I2C? I haven't quite figured that out.
Well, let me get, let's see, Rainbow Arduino version 3. Yes, Rob and I have been going back and forth probably a dozen times today, emailing, and he got his working. Let's see. Where is its connectivity? 12 channels. Yes, it is using I2C. And I do not see how many.
Yeah, I know you can link them together. In fact, if you look at the picture, you can see how they link together using the edge pins and the edge boards. So I wasn't quite sure how many they could put together. It's a neat idea, though, to do it that way. I'd never seen it before, so it's very interesting to see that. But you said Rob's got it working now.
He got it working, and just as we started the show, my email dinged, and he just sent me another email because the last one I suggested that he go back because we've done a couple episodes with LED matrices and LED displays, 7-segment, 14-segment, and I've had some code to do scrolling and letters and things like that. And I just got his answer back. Just as we started the show.
Yeah,
so
no, I had sent him to one of the other shows, but not knowing that the Rainbow Arduino was specialized, I thought he was running like an Arduino, another version of Arduino, and looking to do a matrix. But I realized they're using the MY9221 chip to do that.
Yeah, and the reason I had the data sheet, I was close to the data sheet, is I was looking at this, and I may very well go ahead and order one this afternoon or this evening.
Right.
Yeah, just because it does look interesting. Yeah,
it does. It looks like interesting to me too. I might try to order one of the Rainbow Arduinos and just see how it works. I'd never seen one before, so I wouldn't be able to answer them, in great detail. In fact, I've never even seen that chip before. It's not a very common chip. It's very hard to find.
It's not a common chip, but it is an interesting product. And since I've done on the show, we've done, matrices and displays before. I thought I'd look at it, but he did get it working this afternoon. So I congratulated him. So
yeah, that's good news. All right. So let's see. So that was Rob D. We also had Dave Spalding. Was that this week or last week? He's still here on my list. I think that might have been last week's, actually. Okay, we'll skip that one. All right, so next Monday, we're actually going to not do a show. And next Monday is Labor Day in the United States. And we're going to take the day off and spend it with family and things like that. So we'll be back on the 9th. So next Monday, don't come looking for us live. But when we come back on the 9th, I think we're going to have a special guest. We have somebody who from a chip manufacturer named John Hall. Hopefully he's still good with the 9th. I think he still is, from what I understand from the email. But if he is, on the 9th, we'll have him come in, and he's going to talk about I2C or I2C. This company, he's like an I2C expert, so he can be able to give us a little bit of history there, as well as where things are going with it. I'm kind of looking forward to that.
Yeah, I am too. That should be an interesting show.
Right. Okay, and then let me show you this before I go too far. I was just talking to Bob before the show. I have these motorized faders. So basically, it's a 10K fader. It's 100 millimeters long, and on the bottom you see a little motor. And I don't know if you can see it on the end, but there's a little belt in there that runs around that motor head and moves the fader. So a lot of soundboards use these. So when you change layers on the soundboard that are digital, they'll move the fader to where it should be for that layer you're on. So I just got these this week, a project I'm going to use them on, and I'm going to start playing with them. So it'll be interesting to see how that works. I might be able to do a little bit of a sideshow for one of the episodes about how I got it to work. Very interesting stuff.
Yeah, that should be interesting for me, since I really don't know that much about audio and video and how all of the stuff that you take care of in the background for this show happens. So I'm looking forward to that.
Right. I mean, we talked about before. I'm working on this. This is one of my weak points with doing this kind of stuff. This is the switcher. Now, this isn't the switcher itself. This is a board that I drilled to put the boards on, so I don't have to keep holding them sideways and pushing the button to test them. So this is just temporary, but I have to come down here really soon and start making the physical side of these boards or of the consoles, and that's something new for me. I've never done physical design of a box before to fit something like this. So, but this fader kind of goes along with that. It's a side project to the same thing, because like the switcher I use that's going to control has audio in it, but I don't use it because it's too hard to control. There's no physical control of it. So if I can get physical control of it, it may be more useful for me to use it versus using an external soundboard, something like that, or even not just me, but other people as well. So I was kind of interested to get it to work. All right. So next week, or not next week, 2 weeks from now, we have 2 requests: motor controllers, which I've built a motor controller. I haven't tested it yet. It's sitting on my desk waiting to be tested. And then encoders. Encoders is not that long of a talk, so I'm going to try to probably put these in the same show at some point, or whether it be the 9th. If John's coming, I might wait for another week. But encoders are very simple to use, but they're a little complicated to understand. So I have some different encoders, rotary encoders, and I'm going to talk about rotary encoders. And on the same show, I'm probably going to do motor controllers at the same time. With the motor controllers, we're going to do steppers and DC motors both. The motor controller I have can do both, so that's something we'll look forward to for that. All right. Now, have you been looking at the website recently, Bob?
Not in the last week or so, no.
So the store is up, although it's having some issues. It has this weird blinking thing going on. So I have a support case open with them right now to figure out why it's doing that. And then I have other parts that are ready to go up there too. I'm holding off before I put them up there to figure out what the problem is. But
okay.
There's shields out there. I have more shields coming. I don't have all the parts for all the shields. That's why I'm not all active yet on the site, but they're all up there. They're just kind of disabled to get all the parts for them. So we're getting closer on that.
Yeah, and I've just before the show we were talking about I'd almost finished soldering up the first board that I have for the store. I ran out of gas last night and could not finish.
That's me. I get right to, I'll stay up and I can do it. I know I can. Then I get the part. I just can't do it anymore.
I was I was exhausted last night, so so I'm almost close to that board, and then it'll be on the store as well.
Good. Awesome. All right. So this week, we're going to talk about how to use an Arduino as a mouse and a keyboard. So there's only a few Arduinos that can do this. The Arduino Leonardo is probably the most well-known one to be able to do this. I found out today the Arduino Micro and the Arduino, which one is it? Duo. The Arduino Duo has it as well. So those are the only three that can do this, but let's go back here and we'll show you what we have laying over here. It basically is just a Arduino Leonardo, and you see right here is a joystick control like we used in one of the other shows. I can't remember what episode it was. And then we have 4 buttons. So what I'm going to demonstrate is how we can use this joystick to control a mouse, and also how we can use the buttons to send keyboard commands across. So the first thing I want to do is go look at the code and get that up here. And what you'll see here on the code, at the very top, we define our X and Y pins right here. And then what I'm calling a mouse button is really the button to the joystick. And if you look at watch the other episode, the joystick I'm using has an X and a Y. And then if you push it down at the top, it is a button press. And then I'm going to define the value that I read in. So what I have here is X and Y is on analog 0 and analog 1. And then the mouse button is button or input, digital input number 6. The X and Y value are what I read in from analog 0 and analog 1. And then the move variables are calculated. And we're going to walk through that a little bit later, how I calculate the value to move the mouse. Then we have the 4 buttons right here. So button 1, 2, 3, and 4 are on pins 2, 3, 4, and 5. In our setup, I am configuring the pin mode for the mouse button to be an input pull-up. And then I also define all 4 of the buttons to be the same thing. Now, I actually added some debugging code, and I left it in here because it's very, it just actually shows you visually a little bit better what the button's doing. And I used pin 13 because that's every Arduino has, or just about every Arduino, has pin 13 on an LED. So I just used pin 13. Here we say mouse and keyboard, and we do the begin. So this starts up the mouse and the keyboard drivers. And then we go into our loop. And this is actually a very simple program, and it's not very long. So what I'm doing here is I'm reading the X and the Y values by doing the analog read from the X and the Y pin. And then I check to see if the X-axis has changed. So here's going to be a little bit confusing by looking at it, but you see here I'm doing this if it's less than or equal to 510 or greater than or equal to 520. And the reason I'm doing that is this particular joystick doesn't always return exactly to the same value when you let go of it. It typically comes back to 514 or 515 in that range, but it bounces around. Sometimes it'll come back as 512, sometimes it'll come back as 517, for example. So I left a little bit of leeway depending on where it comes back to say that this 10 range, or this value of this 10 value range, is like a slop zone, so it can come back anywhere in between those. So if it is less than or equal to 510 or greater than or equal to 520, you got to remember Arduino reads in between 0 and 1023 on the analog port. So this 515 is basically about half. And basically what I do is I take the value that's read in, and I do this map command. And we talked about the map command a couple times. I think the last episode we talked about the map command was in the VU meter sketch, if I remember correctly. But basically what map does, it says, I want to take this value, and my values are between this value and this value, and then map it to the equivalent of these two numbers. So you see right here, I did 0 to 1023, which is what the Arduino is going to read in the analog port. So if I read in a 510 value, I figure out where in that range the 512 value is, and then I convert it to these two, one between these two values. And here you see I'm using negative 40 and 40. That's because to move the mouse in the upward direction, you take negative numbers, and to move it in the downward direction, for the x-axis, you would use positive numbers. So the more I move the joystick, the faster the mouse is going to move. Eventually, it's going to get to the point where it's always sending you negative 40 or 40 when I push it far enough. And if the value is not outside these ranges, I'm going to say I don't want to move it. So I'm going to say its x move value is equal to 0. I do the same thing with the y value, and this is the left and right value. So it's its center is not always exactly 514 or 515. It bounces around a little bit. And even sometimes it's sitting still, you see the value change by a number. So this little slop area is just so we don't react to something that's not us doing anything. And I do the same thing. I map it. The y value, again, the range is 0 to 1023, and the values for the mouse move are negative 40 to 40. And if it's not outside these values, I'm not going to move it in the left and right, so I set it equal to 0. Now I check right here, and if I have a value that's not equal to 0, which means something needs to move, I'll come down and do this mouse move. And mouse move is very simple. You have the y direction, which in our case is left and right, and then the x direction, which is up and down. A positive number goes either down to the right, and a negative number goes left or up. So I basically tell the mouse to move right there if there's a value set. Then we're going to come down and we're going to check the joystick button. And if it's pressed, I'm going to do mouse.click, which basically simulates a mouse button being clicked, the left mouse button. Then we're going to read our buttons, and I did multiple things in here to show you different ways that you can do keywords. So if the first button, which is our white button on our screen, this one right here, we're going to send a capital A. So you see I'm doing keyboard right. Right sends out a single character to the keyboard. And if the second button is pressed, I'm going to do a keyboard print. This, just like the serial print, can be a string. So you're going to see when I press this button, which is this blue button right here, that I'm going to send this string out. This is a sequence of characters. And we're going to see this actually work here in a second. If button 3 is pressed, I'm going to simulate of holding down the left shift button and then sending a lowercase b, which will make it a capital B. But you see here I have to do keyboard press, and then I have to say key left shift. Then I'm sending out a lowercase b, which will be translated to uppercase B because it thinks the shift button is pressed. And then I do a release all because this left shift key press will stay down until I do a release or release all. And if button 4 is pressed, I'm going to do this key left GUI, which on Windows is the same thing as pressing the Windows button. On a Mac, which I am on, is the same thing as holding the command button. So I'm going to do, basically on a Mac, command V, which is paste. And I do that by doing the key left GUI, the letter V, and then I do a release all. And then I delay 100 milliseconds. Now, the one thing you're going to notice when I go through this is I didn't put any debounce code in here. I should probably put code in here. You're going to see me hit the button once and then pick up 2 or 3 times because the debounce code's not in here. That's something that can be added to improve this sketch. So here's what I'm going to do. I'm going to go ahead and hop over to a text editor. And on the screen here, you can see that on the right-hand side is me with the Arduino, and on the left-hand side over there is the code. And I'm going to make this window so it has big letters so you can see what it says. Let's go up to 24 characters. And first thing I'm going to do is, you probably can't see this real easily, but as I move the joystick, you'll see the mouse moves up, down, left, and right. And if I go just a little bit, it goes slow, and if I go a lot, it goes fast. So it's variable in speed based on how far I move the joystick. Now I can't really click anything here. I just can do this. Let me go move the window. So I'm going to click, and there we go. See, I clicked. You can see it pops down. So that's just like me pressing the mouse button, left mouse button, just like that. All right, so let's go look at the buttons. The first button, as I said, is going to be just a capital A. And you see it sent out 2 because my button debounce isn't there. There's just 1. But you can see I'm sending out A. And if you remember correctly, I said the second one sends out a string. So I'm going to press the blue button, the second button. And you see there it is. And it sent it twice, again, because it needs to be a debounce there. This is a sequence of characters. And I can do it again. And we just keep putting that as many times as you want. And then the B, the red button, is the capital B, but we're going to do a shift and a B, which brings out a capital B. Now, as an example, I'm going to highlight this, and I'm going to copy it to the clipboard. And I'm going to move the mouse down here, just like this. And now I'm going to hit the green button. This is going to paste what I just copied. And it pasted it twice because of the debounce issues. But there you go, it pasted it. That's the same thing as doing Control V. So there's a couple of things that this could be used for. So in my case, I can think of a project that I'm going to be working on that I was thinking about making a touchscreen interface because I didn't want to put a keyboard in. It's basically, it's a PC-based application. But now that I think about this, there's not really any reason to do a touchscreen if I can do something simple like this. It just has buttons because I don't need any mouse input. I just need to be able to answer a couple of questions, and I could write the program. This is a Windows kiosk type thing, and I could write the code around buttons. I can get bigger buttons that look more like the buttons that are on the old video game machines. You can still get those buttons around, and that would be another option for a button. I could also, if I wanted to get some kind of, I could put a joystick on there to move the mouse around, although I don't think I want to use a mouse. I want to do it completely mouseless because it's really a simple yes-no type question. So that's one application. The person who asked me about this had some kind of device that had a keyboard and a mouse attached, but wasn't really like a PC. It was something specialized, and he wanted to be able to remote control it. So he wanted to be able to plug in something that he could remote control over the network and have like the Arduino send the codes out. So he would write, I don't know, if it was an iPad app or what it was, but it would somehow control the device remotely. In their Arduino would send the keyboard output to it. That's kind of where what he wanted to do with it. So when I started investigating this, I realized how simple it really was, and I was actually pretty amazed because I never really looked into the virtual keyboard. In fact, I thought until today or yesterday that the only computer or the only Arduino that would do it was a Leonardo, but I was wrong. The Duo can do it as well.
Yeah, I thought it was only the Leonardo as well. So that's interesting that the other ones can do it too.
Yeah, it's very interesting. I was surprised because that was news to me, and I was surprised at how easy it was. I mean, I was thinking it was gonna be complicated, but it's, if you can just do a print like they can do a serial print to the keyboard, it's pretty simple.
Yeah.
So I can think of a couple other uses for something like this too. I mean, you could make games that have control pads. So your game may run on a PC, but it would have like your own control pad. Most games have keyboard shortcuts. For example, a lot of things. What is it? Is it XXW or ADWX? A lot of games use for going, forward, left, right, and back. You could use something like this to control it, versus make your own controller. Because you can send out any key combination that you want, so it makes it very, very flexible.
Yeah, and you could have all the hotkeys with a button. That's right.
Yeah, I mean, I've been looking for these, the buttons that they use when they have the competitions. So you hit the button to send off the alarm, like you're the first one in or whatever. I found a place that sells those, and
okay.
Well, the reason I wanted, it's a whole different subject, but it was for my dog. I'm trying to train her that when she needs to go outside, she hits the button. Well, that's the idea. Because I have some friends that train their dog to ring a bell, but I don't want a bell. I want something that's not hanging on the door that's going to ding every time I open it up. So we figured we'd try to do the button thing. So, but I found buttons like that. You could do something like that. It could be multiple inputs. If you want to do your own race game, you could create a program that this would be A through F would be the buttons that everybody's pressing, and when they hit the button, the first one in sends the code in, and that's who wins. There's a bunch of things you can do with it like that.
Yeah.
Very, very kind of neat. So, all right. So that's it for this week. That was what we had, the big thing to talk about.
Okay.
Like I said, next week we're off, and if you go to tech-zen.tv, the program that I just walked through will be out there in the next day or so, so you can download it and try it yourself. if you have a Leonardo. The funny thing is Leonardo is actually cheaper now than the Unos, which I don't quite understand. So
it looks like it's in manufacturing. The
yeah,
chipset that they're using is, the Leonardo that I have. It looks like it's a less expensive chipset that they're using, just because it's newer.
then
And
that could be. That could be. My only complaint, I guess, with it is that it uses the small USB. So everything else I have, all the other Arduinos use the big USB. So
yeah, it does. And of course, I went and dug through my box of wire to find one, because I
yeah, I
knew
mean,
I had
I
someone
keep a
where.
regular one plugged into my computer all the time. So I just grab it and just pull it over and plug it in. But
Right.
the Leonardo, I'm like, well, I don't have that kind of plug laying here. I have to go find one. So not that, I mean, I have them around, just don't use them very often. Most of my cell phones use them now. So that's where I stole one from one of the chargers from the cell phone, and it worked fine.
Okay.
So just a reminder, we normally every Monday at 9 p.m. do this show, 9 p.m. Eastern, 8 o'clock Central, where Bob's at. You can go to techzen.tv/live and get in the chat room and watch live. But that is not the case for the next Monday. Next Monday, we are going to take the week off because of it being Labor Day. We'll be back on the 9th. So it's important to remember.
And if you are here live, while Mike has been explaining the code, I've been in the chat room.
Yep.
So we have been chatting tonight. So
Good. Oh, Vintage Volt showed up. Yeah, see, I think in the beginning of the show, if you didn't see it, I have a monitor in front of me that's the chat room all the time. But my computer said the fan died, and it's not, so I don't have it. So I have it on my screen. I don't see that. So okay. So
all right.
So there's a couple things, Bob. We can talk about this afterwards too. I want to make a couple of shields that are a little unique, and I probably will do a show. And the video I didn't load up tonight was my I got it all ready to go and didn't load it up. Was the surface mount soldering stuff.
Oh yes, I've been looking forward to that.
Yeah, so I got it all edited, and I didn't stick it into the program. So
Okay.
we'll do that on the 9th too. It's still there. I just got to stick it into the schedule.
Sounds good.
All right. I think that's it. Oh, one more thing. YouTube. If you want to watch us on YouTube, youtube.com/TechZenTV. And facebook.com/TechZenTV too. Go hit the like button. Definitely appreciate that. We've been getting a lot of views. We started another network. Right. What's it called? There's another like a YouTube, and we've been getting a lot of views out there as well. We decided to experiment, and I used the Let's Make It show as the experiment, and it's actually worked out really well. It's what's it called? Daily Motion. It's dailymotion.com. So I mean, the first night, the first video I put up was like 34 views by the next morning. I was like, well, that's a lot more than YouTube gets us in the first 24 hours.
Wow, that's surprising.
Yeah, most of our YouTube views come from our website. So if I didn't put it on the website, I don't know how many views we would have. I can't really distinguish between what's somebody coming to the website and watching or going to the YouTube to watch it. So check out Daily Motion. It's just an experiment for us, but so far it's been working well for us.
Well, that's good.
Yep. All right, everybody. We'll see you next week.
All right. Good night.
Night. For show notes for this show, contacts, and more, go to the techzen.tv website where you can get show notes for all of our shows. We love to hear from our viewers and listeners. We have an email, a Twitter, and a phone number where you can contact us for each show. For details, visit the techzen.tv website and get the show details. You can also make a video and upload it somewhere like YouTube or Vimeo, and then just send us a link. You never know, you may see your video in a future show. You can get all of our shows delivered automatically to your favorite device by going to your favorite podcast website like iTunes and subscribing. Each of our shows also has a YouTube channel you can subscribe to get regular updates. Our shows are also available on most internet radio networks like Stitcher and TuneIn Radio. You can also watch and listen to our shows on Xbox, TiVo, and Roku. You can even find us on your Zune.